Alright, today in this video I'm going to be talking about Cisco's proprietary backbone fast as it relates to spanning tree. Spanning tree! And what do we know about spanning trees backbone fast? What does that mean for us? What does that do? So what spanning tree actually does is, so in 802.1 Delta, it takes about 50 seconds for a port to change from non-designated to designated or root port. So in my topology here, I have switch 1 as the root. What would be switch 2 is going to be the backup root. And then we have switch 4 with the bridge ID of 28672. And then switch 3 is our default here. Now, the whole reason why we want backbone fast is what happens if this link right there were to fail. Now, what we know about spanning trees, we have to predict how the network is going to change and how the network is going to react so we could optimize our network to make it faster. So if switch 4's root port goes down, he's like, oh, I got a designated port. I should just switch that over to the root port. But is switch 4 receiving BPDUs from switch 3? The answer is no, because switch 3 has a non-designated blocking port, so he does not send BPDUs from this route to switch 3. So switch 4 has no idea that he can reach switch 1 via his designated port, Ethernet 0/2. So what is he going to do? If his root port goes down, switch 4 is going to send his own BPDU saying, I'm the root, because he has never heard of the root bridge on that Ethernet 0/2 port. Now, when it comes to switch 3, he's like, wait a second. I'm receiving two different BPDUs from two different switches saying I am the root. So he's receiving a BPDU saying I'm the root from switch 4 right there, and then he's also receiving it from switch 1. So now he has a dilemma. He has a choice to make. So he's like, all right, do I believe switch 4 or do I believe switch 1? So before he moves this non-designated port, he's actually supposed to go through the max age timer to timeout and the listening and learning, which takes about 50 seconds all in total. And the whole point of backbone fast is actually subtract 20 seconds from 50 to cut down the timer to 30 seconds, which is the listening and learning state. But how does switch 3 know how to cut down the max age timer? To open this port up so switch 4 doesn't have to wait 50 seconds, he only has to wait 30 seconds now. The way that switch 3 does this, he sends an RLQ, which is a root link query, I believe. What is that? Whoa, all this is still here. He will send an RLQ, which stands for a root link query. And what he is saying in this root link query is, I believe the root is switch 1. So he sends it to switch 2, saying RLQ root switch 1 is the root. No, I'm sorry, switch 1 is the root. Switch 2 receives that RLQ and is like, okay, well, I also believe switch 1 is the root. So let me forward that to switch 1. Switch 1 gets it and it's like, yep, I'm still the root. So I'll send an RLQ response back till it gets to switch 3. And then switch 3 is like, oh, okay, I am getting two different BPDUs saying two different switches are the root. But the one I believed first was the root is still the root. So now I'll open the port up right here to tell switch 4 that he is not the root, switch 1 is the root, since he lost that link. All right. Now, I have to show you this because me just telling you this happens we need to back it up with some actual hard facts here. And the thing about backbone fast is all switches throughout the network need to support it and enable it. If not, when switch 2 gets that RLQ BPDU, he's not going to do anything with it. He's just going to ignore it, really. So we need to enable it. So in the topology I have here, it's just set up like this. And as of right now, switch 2 and switch 1 do not have backbone fast applied. Only switch 3 does. So let's create this failure and do some debugs and see if switch 2 will send an RLQ response or forward that query. All right, so let's get to it. Let me clear that off. Let's see here. Let's move this. So I already have debugging turned on for switch 3. And then I have switch 4. Where's switch 4 at? Oh, I don't even have it on. Well, I'll bring up all of these. There's switch 2, switch 1, and switch 4. Move that. And right now, I'm only focusing on this link and then what the debugs we get from switch 3. All right. Let me verify the topology here. So switch 3, 0/2, Ethernet 0/2 should be having the block port. So we'll do show spanning tree. And that looks correct. And verify that switch 1 is the root, show spanning tree. And it is. Cool, cool. So let's shut down Ethernet 0/3 on switch 4 and see what messages is sent out between switch 2, switch 3, and if switch 1 gets anything. Config T 0/3. Let me move this real quick. There you go. And let's shut it down. Bam. All right. So we keep getting BPDUs sent from switch 4 here, seeing herd root with the priority of 28.673. And then we do a topology change notification and no RLQs were sent. And let me verify that spanning tree backbone fast is applied. It is applied. And notice we actually sent out some requests. We didn't see it in the debugs, but we actually sent it out. We saw it was sent out 9 times. It's because switch 2 here does not have spanning tree backbone fast turned on. It's disabled. And this is why I said before, spanning tree backbone fast needs to be applied everywhere. So let me go ahead and enable it on all switches. Bam, now they're all enabled. And now let's shut this link down. Actually, no, shut it. Bring it up. So we could see these RLQs being sent and received here. Let's clear this off. Reset everything, and let's re-verify. Show spanning tree. Nope. Show spanning tree. It's blocking. Do show spanning tree. It's learning. Let's go to forwarding. Come on, switch 4. All right, we're good. Now we're back to normal. All these switches now have backbone fast applied. So let's shut it down. See what happens. There we go. Now we got some messages here. So let's verify these real quick. Where's my stylus? There it is. My cool stylus here. Looks like a crayon here. So let's see what happened. What happened, switch 3 here, got that herd root BPDU on Ethernet 0/2, which is here from switch 4. Then we also got a received RLQ response on Ethernet 01, which is actually that link right there, saying this guy is the root, which is actually switch 1 right here. But if we verify on switch 2 and switch 1, we can see that we got an RLQ request. We forwarded out our root port. Switch 1 received it, and he sent out the response as well off Ethernet 0/0. So let me actually clear this off and view what actually happened. So like I said before, that link went down. He sent the BPDU saying that he's the root. Switch 3 had to make a decision. Said, okay, switch 1, are you still the root with an RLQ request? Switch 2, forward that to switch 1. Switch 1 sent out an RLQ response saying that I'm still the root. Switch 2 forwarded it back to switch 3, and now switch 3 was like, okay, what I believed at first is still right. I'm going to open this port up. I'm going to change it to designated, and then now switch 4 is going to have that as the root port. And that's what happened, and that's what we saw. And if we see here, we can see that it should have went to designated. There you go. Receive that RLQ BPDU, change in Ethernet 0/2 to a designated port, and switch 4. If we do a do show spanning tree, now Ethernet 02 is his only root port. Okay. Now all this information can be found on the internet, of course, on blog.ine, Cisco's website right here, and also networkinglessons.com has spanning tree backbone fast and how it works and stuff like that. So I just wanted to make a video on how this works. Backbone fast, again, is for 802.1 delta. It's a way to speed up the convergence process from 50 seconds to 20 seconds. And I explained how it worked with those RLQ messages. Whew. All right. So if you have any questions, go ahead and leave a comment below. Subscribe. If you want to request any messages, go ahead and do it as well. So I hope this was informative for you, and I'd like to thank you for viewing.